Hi there everyone in groups 1 and 3 of financial management. I hope you've had a fantastic Easter, and I know that it's a bit of a challenge to slot some study in there, so well done those of you who have done that. And I've been getting a few emails and seeing a few posts of those who have got some concerns with how they're grasping this material, and I guess I would just encourage you to hang in there and keep being active on the discussion boards and making sure you're reading all those posts, because that is definitely the best way to learn. It's very heavy on the formulas and the mathematics, this unit, but you will find if you're able to keep hanging in there that it does all pull together. And this capital budgeting section is a critical section because we actually do have a look at the way we would evaluate projects, and we're putting together a whole range of the things that we've learned and the concepts to date. Now, okay, so what I'm going to do is I'm going to go through a couple of pretty straightforward things here on the screen. As you can see, you haven't got my talking face. I thought that it would be more beneficial for you to actually see some working, so what I'm going to do is I'm just going to screen capture my screen here. So the first thing I just wanted to quickly discuss was the just some basics here about what discounting is. Now, please don't jump up and down. I know you're a long way past this this basic stuff, but in a really practical way, it's really the reverse of compounding. So being able to discount cash flows is obviously the crux of what we're doing here in this unit, and all of the different formulas that you look at, whether it's for an annuity or whether it's to value a share, these are all just different representations of the discounting formula. And obviously with an annuity you need to discount the first payment, the second payment, third payment, fourth payment, all the way through to the last payment. And with a bond, you need to discount the annuity section as well as the lump sum payment at the end. So it's all about these identifying the discounting that needs to be applied given the timeline of these payments. So really it is all variations on this basic formula. PV equals future value divided by, let's just say, X. Okay, so if why don't I make this a bit more practical, and I'll say 1 plus X, or R as we usually call it. Now, if I wanted to discount one period, that's all I need to do. If I have $100 that I'm going to get at the end of the year and it's currently the start of the year, I just divide it by 1 plus the interest rate. Okay, so I'm getting 10% interest rate. I divide it by 1 plus 1. In exactly the reverse way that I would do if I said I've got $100 now, and I want to know how much I'm going to get at the end of the year. I'm just going to go PV times 1 plus the rate. Now, of course, when we have multiple periods, we do this exponential compounding of our interest, and the same thing happens in reverse for discounting. So PV then becomes future value divided by 1 plus the rate to the power of n. Okay, so I know you know this, but it's really handy if you can actually really embed this into how you think, and every time you look at a payment you're thinking about this function. How would I discount that to present value? This is pretty much all of the formulas we're doing is a form of this this function. So for example, if we look at the present, I'll just turn that off, the present value interest factor of an annuity, okay, we know that that is this. All right, now what happens when you have a minus in front of your exponent? It's the same as saying divided by, okay? Now, some of these things, you might miss some of these intricacies unless you actually are really up to speed on your algebra. But this formula here, we're actually saying 1 plus r to the power of, we're actually saying divided by 1 plus r to the power of t, which is the same as 1 plus r to the power of minus t. Okay, but it's just the way we've represented it so that we can actually then divide it by r. But it has the same impact. Okay, so I could equally write this as 1 divided by 1 plus r to the power of t, beg your pardon, and then I could say times 1 divided by r. Okay, so that is basically the same function.